Hello guys, welcome back to DSA playlist by 2am Coder. We are covering sorting techniques in this playlist, and in this video we are going to talk about bubble sort, which is the easiest sorting technique in all the sorting techniques available, and this is the worst in terms of time complexity. So we'll see and we will cover everything. So without further ado, let's get started. So guys, let's consider this is the array, and in this array we are going to apply bubble sorting technique to sort the array. So basically in bubble sort, we swap the adjacent element in such a way that the greatest element comes at the right side, and eventually we will have the biggest element at the end. Once we have the biggest element at the end, we will eliminate that particular index and try to find the greatest element with the rest of the array. So if you see the array, what is the biggest element here? It's 15. So the correct position of 15 is index 8. It should be here. And once it reaches here, we can say this part is sorted because now 15 is at its correct position. And same thing we will do in rest of the array. And again, we will try to find the second largest element, which is, you can see, 12. And the correct position of 12 is index number 7. It should be here. Once it reaches here, we can say this part is sorted. And now we don't need to consider this particular portion, and we will apply the same logic again in this particular portion of the array. So quickly, let's write these steps we are going to follow. Step 1 will be take 2 pointers to check the adjacent elements. Once we have 2 pointers to check the adjacent element, if left element is greater than the right element, swap them. Okay, so you can see in first two indexes, the left side value is greater than the right side value. So this will swap. 2 will come at first position and 9 will come here. Okay, in this way we will keep moving this 9, and whatever the greatest value we will find, we will keep moving towards the right side so that we will have the greatest value at the end. Once we have the greatest value at the end for that particular iteration, we will do the third step. Shorten the array by decreasing the endpoint. So basically, because that particular portion is sorted now, we don't need that index value. So we will shorten the endpoint, because in the for loop we write the condition, right? From which position to what position it should run. So we will decrease the endpoint. So since we need 2 pointers and those pointers should be adjacent always, so first pointer I'll consider as j, and this pointer will be, since it will be adjacent, so this will be j plus 1. I can write j plus 1. Let's write the core logic here. So basically what we need to do, we have 2 pointers, and now we have to check something, right? If the left element is greater than the right element, we need to swap them. So if array of g, if it is greater than array of j plus 1, we need to swap them. And we need to do it repeatedly from this to endpoint, right? So for that we need loop for int j, because we are considering pointer as j, so that's why I'm initiating with j. Always it will be from 0, because we are checking and swapping from 0 till the last index. So as of now, I am assuming that always I will go till end, and later we will see how we can decrease in each iteration. It's not equal, it should be less than. So here you can see we have j plus 1 as well. So j should always go to this particular index because we need j plus 1 as well. If I go till this position and j plus 1 will come here, which is 9, it will give me index out of bound exception. Okay, so j should always go till this position. That means end index minus 1. So as I have written here, j should be less than array of length. So array of length is 9 and j should be always less than 9. In that case, j will go till this particular index. Okay, but we need j till here because we need j plus 1 as well, right? So in that case, I'll write here minus 1 as well and j plus plus to increase the index value. Let's keep it in the first position. Okay, so this is the core logic we have. So basically what we are doing, we are iterating from 0 to last index minus 1 and we are checking the adjacent element. So let's check. J is 0 initially, j plus 1. So j is greater than j plus 1, 9 and 2 will swap. So we have swapped the first adjacent elements. Let's do this with the next step as well. So since we have swapped it, again it will go to the for loop. It will increase the value of j. J will come here and j plus 1 is nothing but 2. Let's remove this. This is not even required. And the second pointer is anyway, it's j plus 1. So the next value itself, right? So now j value is greater than next adjacent element, which is 1. So again we need to swap it. Again j will move to the next index. Now again value of j is greater than j plus 1. Swap it. 7 will come here. 9 will go here. Again increase the value of j. Again it's greater. So 6 will come here and 9 will come here. Again we will increase the value of j. Now you can see the value of j is lesser than the value of j plus 1. So we will not swap it. We will just increase the value of j. Again value of j is less than j plus 1 value. We will not swap. We will just increase the value of j. Now again the value of j is greater than value of j plus 1. In that case we need to swap it. 4 will come here and 15 will come here. After swapping, increase the value of j. Again value of j is greater than j plus 1. We will swap it. Now since we are saying it should be length minus 1, which is 8, and it should be less than that, so it reaches the end point. Now you can see 15 is the greatest element and it reaches the end, which is its correct position. Okay, so now we don't need this. We need to eliminate this particular index. We need to check again for the second largest element. Okay, so for now let's keep this logic as same and we will do the same thing again. Since 2 is greater than 1, then we will swap it. 1 will come here, 2 will go here. Again we will move the j value to the next. Now again check j value is less than the j plus 1 value. We will not swap. We will simply move it to the next index. Again the value of j is greater than j plus 1. We will swap the elements, move the j to the next index, and again it's not greater than the j plus 1 value. We will not do anything. We will move it to the next index. Again move it to the next index. At this time it is greater than the next element, so we will swap it. 4 will come here and 12 will come here. Increase the value of j. Now the value of j is greater than j plus 1. Again we need to swap. 5 and here comes 12. Again, now we cannot move j value here because we have already finished this particular index, right? Now we have to check till this index. So in that case we will move till this particular index. We will not move here because for second iteration this is the last index and we need j plus 1 value as well, and j plus 1 is already sorted. If we go here we don't need to check here again. Since we have eliminated this and this particular portion is also sorted, we will eliminate this particular portion as well and j will start from 0. So as you can see, in first time we did not eliminated any index, but in second iteration we eliminated the last index and now we have eliminated the second last as well. We keep on increasing the eliminated index. So here, and also we are repeating the core logic here again and again, right? So that means we need another loop. So let's consider, I'll write another loop which I will consider the pointer value as I, which will start from 0 and it will go till array of length minus 1 or array of length only. That we will see later, but for now let's keep it like this and increase the value of I. It should be gth. Now initially the value of I is 0 and initially we did not eliminated anything, and once the value of I becomes 1, that means we completed this particular portion and again we have repeated this. In that case I will become 1 and we have eliminated first index. So if I write minus I here, let's see how it will look like. Because as I value is increases, we are also decreasing the end point with each increment of I value. Okay, so now j is here and let's consider it is here. We have not eliminated anything. In that case I value is 0 and this particular portion, the value of this particular portion will be array of length, which is 9 minus 1, which is 8, and j should be less than 8. That means j will go till this index and j plus 1 we will check with the j plus 1, which is index 8. Now with the first iteration we have the largest element at its correct position, which is at 8 index. Now we have to eliminate this. In that case, again, since we have completed the inner loop, it will come out of this loop and go to the outer loop and it will again start, and the value of I will increase and j value will be 0. J will start from 0. Since the value of I has increased to 1, array of length minus 1, which is 8, minus 1 is 7. Now j value will go before 7. It will not reach 7. That means it will go till 6 index. So in that case we are saying we have eliminated this and j plus 1 will be 7. Since this iteration is completed and j will become 0 again with increment of value I. Now the value of I is 2. Let me write the value of I here as well. I value is 2. Now when the I value is 2, again we have to eliminate this particular portion, right? So array of length minus 1, which is 8, minus 2, which is 6. So that means it will go till 6. This is the last index and j will always be less than 6. It cannot reach the pointer 6. Okay, now again we check the adjacent element. J is not greater than j plus 1, it will go to the next index. J is not greater than j plus 1, it will go to the next. Same, it is not greater than the j plus 1. Now j value is greater than j plus 1. Now we have to swap 9 with 4. increase the value of j. Again, the value of j is greater than j plus 1. 5 will come here, 9 will go to the next index. Since j should be less than index 6. Okay, now I can write endpoint here as well. End of j. I can write like this. It's 5. Because it cannot go to 6. It should be less than 6. In that case, it will come out of the inner loop and value of I will increase. This will become 3. And again, j value will be 0 with inner loop, and j will go till array of length minus 1, which is 8, minus I, which is 3. 8 minus 3 is 5. And j should be always less than 5. That means it should be 4 in this iteration. Now again we will check if value of j is greater than j plus 1. No, it is not. Now if it is greater than j plus 1, no, it is not. Again it is not. Increase the value of j. Now value of j is greater than j plus 1. We will swap it. 7 will come here. Increase the value of j. Now again value of j is greater than j plus 1. We will swap it. Since the end of j is 4, we will stop here, and now again the inner for loop will end and it will go to the next outer loop. Value of I will increase to 4 and j will become 0. Array of length minus 1, which is 8, minus 4, which is again 4. Now this condition is not satisfied, so it will move to the next index. Again it is not satisfied, so move it to the next index. Now the condition is satisfied, so we need to swap. 4 will come here, 6 will go here. Again move it to the next index. Well, this condition is satisfied again, so we need to swap 5 with 6. Since end of j should be 3 here. Since j has reached to its end, it cannot go further because this condition will break and inner outer loop will break. Again the value of I will increase to 5, j will become 0, and the end point of j is array of length minus 1, which is 8, minus 5, which is 3. So j will go, so j should be always less than 3, which is 2. Value of j is greater than j plus 1. No, it is not. So we will not swap and increase the value of j. Again it is not satisfied. Again it is not satisfied. So we have to stop here because the end of j value is 2. And this loop will break. It will go to outer loop, increase the value of I to 6. J will be 0 and end of j will be minus 1 because I value has increased. This will go here. Now the value of j is 0. Sorry. Now the value of j is 1, which is not greater than 2. We will not swap and move it to the next index. With this step, we will come out of the loop because it's the last position, and now we cannot swap because it is lesser than j plus 1. In that case, increase the value of I, it will go to 7. Make the value of j as 0. Increase the endpoint because I value has decreased the value of end of j to 0. And this will become like this. Now again we need to check this condition. As you can see, this is not satisfied and it reaches the end of j. It cannot go to index 1. This will break the inner loop, and outer loop will increase the value of I to 8. And again, the value of j should be less than array of length minus 1 is 8. 8 minus I, which is 8 again. 8 minus 8 will become 0, and j should be always less than 0. And here the value of j is 0, which is not satisfy this condition, and it will break the loop, and it will come out of the for loop of outer loop. So you can write here -1 as well, or you can keep it like this also, because unnecessarily we will have extra iteration. So as you can see, this array is now sorted. This is how the bubble sorting work. We have to swap adjacent element if the greatest element comes at the left side, and we have to keep swapping until we find the greatest element and we put it at its correct position, which is the most right position. Yeah, so let's code this in IDE. Let's quickly create a class for bubble sort. So I have created one method here which will take array as a parameter, and we will write our sorting logic here inside the method. We are simply displaying before sorting and after sorting. Let's display this. So as of now it is not sorted because we need to write the logic here. You need to call this method. So first call this method, pass the array, and for the logic we will copy this. Okay, for swapping, let's write swapping logic here. We'll have temporary value. Yeah, that's it. Outer for loop will go from 0 to length -1, increase the value of I, and inner loop will always be from 0, and it will go till array of length -1 minus I, because we need to eliminate the last index on each iteration, because we will have the greatest value at its correct position. We need to eliminate that. Initially it will be 0 because we are considering last element. Once I will become 1, we will eliminate the last index, that means -1. Okay, so let's run this. So as you can see, this is sorted. 1 2 3 4 5 6 7 9 12 15 25 41. So this is the very easy sorting logic, and this is not quite efficient because it takes big O of n square time complexity, and in the real time scenario you will never use this sorting technique because it's not good. So for the knowledge purpose and education purpose, you should remember this logic because this may ask in some company interview questions. So this is it from this video, guys. If you liked what you saw, just hit the like button, share with your friends. I'll see you in the next video. Till then, bye. Take care.